Okay, this is going to be a review of things you did last year for sure. I seriously doubt anybody's going to have any problems, but I want to make sure that I'm showing you how to do one-step equations, and I'm showing you how it's going to have to look, even if, it's easy and you can automatically see what the answer is. So it's important to understand that solving equations is based on inverse operations. You know that if I'm adding, the inverse or the undoing of adding is subtracted. I can find a missing addend by subtracting. If I'm multiplying, the inverse of multiplication is division. I can find the missing multiplier, the missing factor, by dividing. I can divide the product by one of the factors. And so everything in solving equation depends on understanding that adding and subtracting are the doing and the undoing. I'm adding and I'm unadding. I'm finding the missing piece that I'm adding. Okay, and multiplying and dividing, they are mates. Okay, they work together. Multiplying is multiplying together, and dividing is finding the missing multiplier. So it's the unmultiplying. Okay, so we just want to make that clear. Adding and subtracting go together, multiplying and dividing go together, which I know you've already done, but I just want to repeat it. I'm now going to show you what the steps should look like in when you're doing equations. And because you already know one-step equations, it'll be easy. You'll already know what the answer is, but I want to make sure that you understand what it needs to look like when the equations get more complicated. So in the first equation, I have 7 plus n equals 15. Now, I could ask you that and you'd say, oh, yeah, that's 8. Okay, but this is what it would look like solving it. I would say I have 7 on this side. I want to get that n alone. So I'm going to take away that 7 from this side. I'm going to take it away. But if I do that, as you know, you have to take it away from both sides. It's because I'm sure you've heard the thing about the seesaw, the teeter-totter. It's a balance. You have to keep what you do to one side, you have to do the other. Okay, so now let's look at that. So that means 7 minus 7 is 0. Okay, and so n is going to equal 8. And while I knew that answer already, it's important that you understand that just like we did in order of operations and the distributive property, you're going to have to show what you're doing, okay? Because like I said, it's going to get way more complicated than this. I am looking at the next problem. Now, notice that in this problem, it's subtraction. But I know that the inverse of subtraction is addition. So I'm going to have to undo, to find the n, I'm going to have to use addition. Okay, so I have 20 equals n minus 4. Well, I want to get that n alone. How do I get that n alone? I add 4 to this side because minus 4 plus 4 is 0. It gets rid of it. But if I add plus 4 on this side, I have to add plus 4 on this side. And then I'm going to get n equals 24. And you could have told me that without doing any work, but I need for you to understand that, again, this is what it looks like. Okay, in the next one, I have 15 equals 5p. And remember, 5p, that's an automatic multiplying. Okay, no sign means I'm multiplying. So I have 5 times something equals 15. Well, I know to find a missing multiplier, I'm going to use division because dividing is the inverse of multiplying. So I'm going to divide this by 5. But if I do one side, I have to do both sides. Okay, so I have 5 divided by 5 is 1. That clears that out. And so I have p equals 15 divided by 5, which is 3. Okay, so notice how I marked that division. All year we've been talking about the fact that the fraction bar denotes division. So it should be no surprises there. Okay, now I'm going to the last one, and it's saying n divided by 2 equals 8. Well, I know that 2 is a factor and 8 is a factor. I need to find out what n is. So n is going to be something bigger than 8 because I've already divided it by 2. The opposite of dividing is multiplying. So I'm going to multiply both sides by 2. So I can, because divided times 2 divided by 2 is 1. And if I multiplied this, I could also say it's 2n, right? Because I'm multiplying by 2 over 2 equals 8 times 2. Okay, that obviously is 1. So that would be n equals 16. And you probably are all saying, yeah, I get this. We've done this before, and that's awesome. I mean, I'm glad if that's what you're thinking, but I wanted you to see what it would look like in a one-step equation, because we're going to get way more complicated than this, and you're going to have to show your work. Okay, so there you go. I do want to go one step further, and I want to talk a little bit about substitution. And you have also done this, but I just want to make sure we're clear. So in this problem, I say if n equals 4. Okay, so if n equals 4, I'm going to have 2 plus n, which is 4. Notice I'm substituting it in, equals p. So I know then that p equals 6. Okay, in this case, it's going to be 6 minus, okay, and I know n is 4, and that's going to equal p, and so p is going to equal 2. So I'm just substituting in. I'm saying that n is 4. I'm getting rid of the n, and I'm saying I know what it is. It's 4. Okay, the next one is 4, and remember, a number next to a letter is times, so it's 4 times, and n is 4, so I'm putting in that 4, okay, equals p. And so we know that p is going to equal 16. In this one, it says 20 divided by n, okay, which is 4, okay, equals p. So we're going to know 5 equals p. Now, these are very easy, but I did notice that people had some issue in testing solutions on Khan with figuring out what they were doing with a variable where the answer was given, the number that it represented was given, and they had to substitute it in, and they seemed confused about how to substitute that in. So all you're doing is you're just replacing that variable with whatever number they give you. Okay, and in this case, I replaced all the n's with 4, and I was able to get a solution for p. Okay, good job.